Here's the multimeter, and it can measure various quantities. So right now it's in ohms mode, so it can measure the resistance of the given resistor. So I'm measuring a resistance of a fixed resistor, a color coded resistor, as you can see, right? And so the resistance of this resistor is exactly 1 kilo ohms. Okay, and this is how you connect actually. So the positive terminal is connected to the this ohms or volt, and the other terminal is always connected to the ground or common terminal. Here's the circuit construction for Ohm's Law Lab. So we're going to do the IV curve, current voltage measurement for 3 different samples. The first sample is this color coded fixed resistor. This is a fixed resistor, 1 kilo ohm we have already measured, but we can also calculate from the experiment. And the second sample is the light bulb, this light bulb, right? And the third sample is this LED, light emitting diode, right? So first, let's do the lab for this fixed resistor, color coded resistor, and this is all the circuits. Usually, all the circuits are constructed on a circuit board called breadboard, and you can check the connections for the breadboard on the manual, right? So first, the power is connected here. First, the circuit board gets power from the power supply. Here this is the DC power supply, and it's connected through the bus. You know, because if you check the connection, these rows are connected together, and there's a gap here, and these rows are connected. So I'm first getting the positive line, right, positive terminal to the sample from here, and I'm running because these are connected only vertically here. So I'm running this. I'm putting an ammeter, right? This is connected to the ammeter in series with the sample, and the negative terminal will go to the negative. So here, and I'm connecting this multimeter. I'm using this multimeter as a voltmeter, which is directly connected across the sample, right? So this multimeter works as a voltmeter. This multimeter works as an ammeter, okay? Because this is in parallel with the sample. This is in series with the sample. So this is how you connect the circuit. Though it looks a little messy, but it's a pretty easy circuit actually. Ohm's Law Lab circuit is pretty easy. So now let me get started. So I can now get started with putting 1 volt, right? It's almost 1 volt. So what's the current? 1 milliamp. So write it down. So now I'm gonna slowly change to 2 milliamp. So I'm just fine tuning. It doesn't need to be 2.000, So at 2 volt, right? So at 2 volt, it's 2.01 milliamp. At 3 volt is 3 milliamp, right? Pretty straightforward. At around 4 volt, it's about 4 milliamp. Let's say at 5 volt. At 5 volt, right? It doesn't need to be exactly 5 volts. So at 5.036, you have 5.04 milliamp. Remember, this is in milliamp. Okay. So, and then let's go to negative cycle. This is positive scanning, right? So we're going to go from -5 to +5. So we have done 1 to 5. Now to do the negative cycle, right, from -1 to -5, you have to manually change it. Okay, you have to manually change this. So I manually change the polarity, and then now we're gonna see from let's say -5. So at -5, the current is negative 4.97, right? So write it down. And now let's go to negative 3, negative 4. Here we go. So at around negative 4, negative 3.99 amps. Negative 2, negative 207 milliamp. Write down the exact number. And at negative 1, almost negative 1 milliamp, right? And let's go to 0. And at 0 volt you are supposed to get 0 milliamp, right, at as expected. So that's for the register. So now I have replaced the fixed register, with the electric bulb. All the circuits are exactly the same. Now again, do the same thing. So we're gonna scan IV curve. We're gonna measure voltage and current. So at negative 1 volt, the current is negative 81.3 milliamp. Write it down. So let's go to negative 2. So about negative 2, right? Negative 2 volt, you have 115.76 milliamp. And at the same time, you can see the electric light bulb is turning on, right? It's on already. So now let's go to negative 3. So negative 3.038. The current is negative 142 milliamp. Negative now 4 volt. Doesn't need to be exactly 4. Negative 4.19. So the current is negative 167 milliamp. And at negative 5 volt is 187.3 milliamp. So again, for the same electric bulb, let's do for the positive positive voltage. So I put positive 5 volts, and this is the current. For positive 5 volts, its current is a 187.4 milliamp. And look at the bulb, actually. Look at the intensity of the bulb. It's so intense now, right? Because you are putting more voltage. And now let's continue. At positive 4 volts, right? 164.7 milliamp. At positive 3, about 3 volt, 140.7 milliamp. So exactly write down the number shown. Positive 2 volts, the current is 113.8 milliamp. And positive 1 volt, current is 82.4 milliamp. And look at the intensity of the bulb, right? It has decreased significantly as expected. And of course for 0, right, for 0 volt you are expected 0 milliamp. So this is called light emitting diode, and it has a light emitting diode has a polarity, So it's a little flat surface is cathode, negative, and the rounded surface, is positive or anode. And in this example, actually here the right electrode is cathode at negative. So we're gonna put this in the circuit, and we're gonna again do IV curve measurement. So now this LED is in the circuit. So again, we're gonna change the voltage and measure the current. So first, I'm gonna measure for the positive voltage, and let's measure the current. And this time we're gonna go very slowly. So 1, 1.2, 1.4, something like that. So first of all, 1.1 volts. First, let's put 1 volt. about 1 volt you have 0 milliamp, right? So there's no current. So I'm going to do 1.2 very slowly. So 1.2 still 0 current. .4 still 0 current. About 1.6 you have now little current, 0.25 milliamp, and that's where this LED is now turning on, right? It's a LED is a very non-linear device, right? So at about 1.612 you have 0.24 milliamp of current, right? Let's put 1.2 1.28 volts. So 1.8 volts you have 5.56 milliamps. See how quickly it is rising. So at 2 volt at around 2 volts, let's say 2.1, you have, see, it's little fluctuating right now, it's 34.5 milliamp. It's little fluctuating. So about 2 volts you have 32.5 seconds, and look at the intensity of the LED, right? It has increased because it's already on. And let's do one more point, 2.6, 2.4, let's say. And you have to be very careful at, because the current has increased significantly. So it's fluctuating. So about 2.6 volt, 2.56 to 2.6 volts, the current is about 65 milliamp, right? And let's do one more, very last one, 2.6, 2.8, about 3 volt. About 3 volt is 101 milliamp, right? It's very large. It's exponentially increasing, and you can see the LED light, right? Now let's do for the negative cycle. So again, I have flipped the positive and negative terminals, and we're going to measure, the current through the diode, at negative cycles. So let's start with -1. So at -1, 0 current. You can go a little faster. -2, right around -2, again 0 current. -3, no current. -4, no current. -5, still no current. So the LED doesn't turn on, right? So that means the LED works only in positive half cycle, right? Positive polarity, right? If the positive terminal of this is connected to the positive of the battery, then it turns on, right? It doesn't turn on in the negative cycle, actually. If you put negative voltages with respect to anode, it doesn't turn on. That's the property of the diode. Diode is a unidirectional device. It doesn't conduct the half cycle.